108, it's good teaching. Oh, this happens. 108, it didn't start right away. T1 is 4, because we're only taking a part of it. R is, I don't know. And then N is 4. Why is it 4 and not 5, Rihanna? Because you're totally right.
Because we took out like the first box.
We just ignored that baby.
Yeah.
Yeah.
So there's only
Yeah, so that we can find R. But there really is 5, correct? But we're only using 4. Okay. Okay, so we're going to divide by 4 first. Yeah. And we get 27
yeah.
equals R cubed. And then how do I get that cube to go away? Cube root it. Someone super whispered that, but they are completely correct, and I don't even know who did it. R is 3. Speak with conviction. You were right, whoever said that. Okay. We're going to times by 3. Was it you? Did you say it? No. Was it Nikki or Aaliyah? Was it both of you together as a combined quiet? I think. Was it just Nikki? Was it just Leah? It was Aaliyah. It was not Gilbert. Okay. He's just like, not today. Okay. How do we get to the next one? Times. See? So smart. Okay, good talk. 12 times 3. Did you figure it out, Sam? Or are you playing a game? Because if you're playing a game, then I backtrack the thing. Oh, good. Carry on that way. You were just so basically, you were still whatever. I'll take it. It was calculated. 12 times 3 is 36 times 3 is
108.
We're so smart. We got there. Now, how do we get backwards? This class is just brilliant. Ending on a high note. That's what we're doing here. So we're going to go 4 divided by 3, which is
1.2 repeating.
True. Do I want you to write that?
Wow.
Fractions. Thank you, Ted. Oh, you just about fell off the wall there. It's just.
I wasn't wrong though.
If it repeats or it doesn't stop, write the fraction. Don't write 1.3 with a dot on it.
Sure.
Unless it's numeric response and they're like, actually near Wisconsin or something. Then go right ahead. Okay? Alrighty. Boom. Down here. This is the one where we have to use the knowledge we learned at the very beginning. So here it says, determine the number of terms. Number of terms is what variable? N. Now, when we needed N in arithmetic, we could just do some math. We could divide, subtract, and boom, we get N by itself. We agree? But in geometric, our N is actually in the exponent. So how did we do that? I don't even know what just went on there. Our N is in the exponent. Probably better I don't. And how did we figure out how to get what was in the exponent? We started the very first part of the lesson with it. We practiced it. It was like, no, it didn't. Yes.
Make the bases the same.
You need to make the bases the same, then we can write the exponents equal to each other and solve. Right? So let's fill it in first. What do we know? We know T1 is 4. And Tn is?
58,732.
Yes. There ain't no stopping you now. You're on the move. Okay. R?
3.
What did you do to get 3? You're right.
Divided.
You divided what?
T2 and T1.
T2 by T1 and T3 by T2, and then you knew it was geometric, right? So we went 12 divided by 4, which was 3, which is correct. Now we need Tn equals T1 plus, that is not the right formula. T1 R, no! My eraser's not working. I need to restart my computer. Not right now. R to the n minus 1. How do we know to use that formula? Because it says what in the geometric sequence, right? It says geometric sequence here, which means we have an R. You also did say that that's completely right. Because it has an R, it is a geometric sequence. So we have to use this one. Not a series because they're not asking us to sum it, right? There's not plus or minus signs between them. Okay, let's fill it in. So we get 78,732 equals 4 times 3 to the n minus 1. And what must you stop yourself from doing? The 4 and the 3 together. Do not put them together. That is illegal in all states, territories, provinces, European countries, Antarctica, all places. So what are we going to do? Instead of multiplying those together, which is illegal, what can we do? Divide the 4 over. Oh, 3, it's a 1. Oh, stupid eraser again. It's gonna be fun. Is that what it is?
Yeah.
Okay. Now what do we have to try and do?
Always incorrect.
Yeah, it's in brackets.
I mean, it's last, right?
Sorry?
It's last, isn't it?
Which is last?
Like, would you divide the 3 now? Or
You can't. We have to make common. Starts with B, rhymes with ace. Base, good job. We need to make common base. What is the small base? Base is what's below the exponent. It's a 3. Good answer. Thanks, guys. So the base is a 3, so I need to make that big kahuna number be a base 3. So I go 3 to the 2. Oh, it's 9. That's not it. 3 to the 3. Oh, it's 27. No, that's not it. 3 to the 4 is 81. And you keep going till you get 1,900. That's not true. 19,683.
Oh, cool.
Right?
Got it straight away.
Yeah. Genius. Told you, Ted. I'm really pumping his tires today. He is just like feeling super smart. The rest of you are also brilliant. I just feel like I'm on like a roll with bugging Ted at this point. What'd you get, Ted?
9.
3 to the 9?
Yeah.
So 3 to the 9 equals 3 to the n minus 1. And what do we do? If this base equals this base, what can I say now? The exponents must equal, right?
Oh,
So if this base equals this base, then 9 must equal n minus 1. We agree? Because it's 3 to the 9 equals 3 to the 9. Oh, then n minus 1. So what would it have to be? 10. If you can't see that, you can actually solve it. So you could go 9 equals n minus 1, add 1, n equals 10. Or you can say, hey, these need to be the same, 9 and n minus 1. So this needs to be 9. Well, n would have to be 10 in order to make that be 9. So now we know it's 10. You try B and C. Go. So we have negative 1,458 equals T1, which is negative 2. R is negative 3 to the n minus 1. Divide by negative 2. And we get positive 7 to 9 equals negative 3 to the n minus 1. Now I told you, you need to have a negative 3 base. If you don't put it into your calculator in brackets, it will do negative, and then it'll take the 3 and raise it to the power, and your answer will always be negative, which is not true. We want to do negative 3 to an exponent, right? So if I do negative 3 squared, it's 9. Negative 3 to the 4, it's 81. Negative 3 to the 5 is 729.
no.
Nope, because that would be odd. It must be 6.
Mm-hmm.
I realized after it can't be a 5 because negative 3 to the 5 would be a negative number, and I need a positive 729, right? Negatives to an even exponent make a positive answer. Negatives to an odd exponent give me a negative answer. And so I get negative 3 to the n minus 1. Now, if this is equal to this, what must n be? 7. Because 7 minus 1 is 6. Okay, let's try this one. So we have Tn, which is 4,096, equals T1, which is 4, R, which is 4, to the n minus 1. I have to divide by 4. And I get 1, 0, 2, 4. 4 to the what is 1,024? 5? Thank you. And then, once again, we have 4 to the 5 equals 4 to the n minus 1. What would n have to be in order to get 5? 6. We're skipping example 5 because it's a specifically weird one that never gets used again. We're going to go here. So this one, they want the nth term. You did this yesterday. Nth term. Nth term just means general term, correct? So Tn stays Tn, and T1 is 2, R is 7, and N is N. So we get Tn equals T1 plus, oh, I'm doing arithmetic. Now I can't fix the race. R to the n minus 1. So we're going to get Tn equals 2, and then 7 to the n minus 1. You guys try box 2 and box 3. You do box 2, we'll do box 3 together. T1 equals 6. R equals negative 18 divided by 6, which is negative 3. So Tn stays Tn. T1 is 6. Negative 3 to the n minus 1. The third box, I told you that we need T1 and we need R in order to find the general. So we're going to have to first find R. We have T1 is 7. We have Tn is 1,792. And if Tn is 1,792, that's 5 terms. So n equals 5. So we have to solve for R first. So we're going to get Tn, 1,792, equals T1, which is 7, plus 5 minus 1 times, woo, I keep going into the arithmetic. My brain is not transferring to human. R to the n minus 1, divide by 7, and we get 2, 5, 6. N is 5. I corrected that. So we get R to the 4. Then we take the 4th root of R. And what does R equal? 4. And then we can fill in Tn equals T1, which is 7, R, which is 4, to the n minus 1. Yay. Here is the word problems. Dun, dun, dun. Okay. So here's your terminology. Paying attention to word problems where I lose people. So we have rate of growth, rate of decay, and percentage of. 100% plus percentage of growth equals rate. Convert to decimal, either first or last. So this one here, let's look at this one. It says the rate of inflation. Inflation means it's increasing or decreasing? Ah, look at it. It's increasing by 3.5%. So what you have to remember on these ones is you'll know that these are geometric sequence or series questions because they're with percent, because you're growing by a rate of percentage, not by like adding 2 each day, like $2 each day or something like that. Now, when we start off with originally the exact same value as everything else, it's 100%. 100% of the previous day's stuff is just the same amount as the previous day, right? If I take 100% of the previous day, I just have the same amount. So let's pretend there was 10 fish on the first day. If I take 100% of 10 fish, I have 10 fish. Same thing. I'm not growing by anything, and I'm not reducing by anything, correct? So you always start off with 100%, and then you add the increasing percent if it's increasing, or you subtract the percent if it's decreasing. So this one, it's increasing by 3%. So my R is actually going to be 100% plus 3.5%, which is 103.5%. Now herein lies the problem. My R doesn't ever have a percent symbol, does it? Have we had a percent symbol in it? No, we just need to have a number. How do we get rid of a percent symbol, do you know? Divide by 100. So if I want this percent symbol to go away, I'm going to divide by 100. And my R is going to actually equal 1.035. So that's the only way I can get the percent symbol to go away. So that's one option. This one says decay, decrease in value, depreciate, a particular percentage less. So if I'm going to depreciate or decrease, instead of going 100% plus the percent, I'm just going to go 100% minus the percent. That's it. So this one here says the number of fish in a lake is decreasing by 2%. So my R is going to be 100% always. But instead of adding 2%, I'm going to do what this time? Instead of adding, I'm going to subtract, yeah, 2%. So I'm going to get 98%, which is lovely. But can my R be in percent? No, how do I get rid of the percentage? Sign. Divide by 100. So R actually equals 0.98. This one says the value of the computer decreases by 1/5 each year. What is 1/5? Type in your calculator. So 1 divided by 5. Yeah. It's 0.2. So we're decreasing by 0.2. Is that a percent? Is that a percent? No. That is a decimal, correct? So instead of going 100% minus the percent, I'm going to do what? 1 minus the decimal. Because 100%, if you want to take the percent away, you go 100% divided by 100, which is 1, right? So if it's actually a percent, you subtract it from 100. If it's just a value, so this 1/5 equals 0.20. I'm going to go R equals 1 minus 0.20, which is 0.80. So if it's not a percent, it's just a decimal, you subtract it from 1. If it's percent, you subtract it from 100. And then we do doubling. This is something to note. If they say it doubles, or they say it triples, or they say it halves, or half-life. If it doubles, if I double 100, what's it going to be? 200%. But then I have to turn it to percent off, right? So I divide by 100. So it would be 2. If it triples, you take 100 times by 3, you get 300%. But then I have to divide by 100, so it's 3. And if it halves, it's a half. So these ones are different than the percent ones. These are special. So D here says the number of rabbits in a population is doubling each year. So R is 2. Now we'll go through an example. So here it says, a truck depreciates. Depreciates means what? Am I going to do? Am I going to add or subtract? I'm going to subtract. by 15% per year. So am I going to subtract it from 1 or 100? Sorry? 100 because it's in percent. So I'm going to go R equals 100%. If it wasn't in percent and it was in decimal, I'd do a 1. So it's 100% minus 15% gets me 85%. But I need to get the percent symbol to go away, so I divide by 100, and I get 0.85. Now we have T1, which is my first term, or Tn, which is my last term, and n is the number of years, right? So let's go through and see what else they give us. If the truck is valued at $40,000 in August 2010, it's either T1 or Tn. We know that. We have to figure out if this is the first term or the last term, so we have to keep reading. If it asks us for how much it's worth in 2020, then this is the first term because it's earlier, right? If they ask us how much was it worth in 2000, then that would be earlier. So then this would be the last one. So we have to look for the year that goes with it and what other year there is. Okay? So we know 40,000 is either T1 or Tn. Let's keep reading. What will its value be to the nearest dollar on August 2016? So is that earlier, the 40,000, or later? 40,000 August 1st, 2010, and they want to know how much it's worth in 2016. Is 2010 before or after 2016? It's T1. Because this one's in 2010. They want what it's worth in 2016, which is a later date, correct? So T1 is 40,000. Now this is the part that messes people up. How do I get N? N is neither 2010 nor 2016. We have to use those years to get N. How do we do it? Yes. So we do the year of the last one minus the year of the first one, and then we have to always add 1. So we're going to go 2016 minus 2010 plus 1, which is 7. What are they making us find? Tn. You try it out. So this isn't a sum. Why? We haven't even done sums yet, so it would be a dead giveaway. It's not a sum. But it's not a sum because I'm just asking for what is the value in 2016. I'm not asking for what is the total value from 2010 to 2016. Total would be sum, right? There's no total in here. I just want what's Tn. So I do Tn equals T1, which is 40,000, R, which is 0.85 to the 7. Now, should my number be going up or down with the value of this truck? Up or down by 2016? Down, because it's decreasing by 15% each year, right? So if you're like, oh, it's like $60,000 now, second guess yourself and be like, that doesn't sound right. So what's it going to be to the nearest dollar? Ted?
Why me?
Because you're on a roll. Please tell me you typed it in.
I have a number.
I believe in you. Believe in yourself. Read the number.
15,085.
Does everyone agree with Ted? Does anyone not agree? They don't talk anyways, Ted. Don't take that as a fact. Do we agree? Disagree?
Don't
Yeah,
you?
I agree.
Because there's like a big long number, like, don't you round it to 2 decimals?
Oh, it's n minus 1.
Nearest dollar.
Come on, Lepp. N minus 1. It should be 6. But what?
It's
Oh, it's
around
near
10
the
years.
dollar.
No, it says nearest dollar. See, they all agree. They're just quiet. Trust in yourself. When they're quiet, it doesn't mean like you're wrong. Trust me. They just.
86 because there's like 0.9.
Oh, yeah, they're right.
Yeah, but it's not like it was a massive difference.
Yeah.
It is for the test, but we're just discussing this, Ted. It's not like you gave me 17,897,000,000 or something, right? Right? Let's all just get along. Let's all just get along. Okay. And then we would write a statement. We would say, on August 1st, 2016, the truck was worth $15,086. You look like you're Babe Ruth pointing that you're going to get a home run or something. I don't know what you're doing over there, Mitch.
That's what I was thinking.
Oh, okay. Good. Good thing I picked it out. Obviously, very good dramatic. Oh, Babe Ruth! Yes.
You got it.
Did you guys not suck so badly? Like, I got that right away. Okay. Write these down. We're going to try 2 over the weekend. 2.
Two?
2.